Hello everyone, I'm Syrus Akbary. Today I'm going to talk about Graphene, but mainly about how we can actually extend the limits of GraphQL. So as a summary, I will do three major announcements, of which I'm super excited to present today. First, I will do an overview about Graphene and how it evolved all this time. And then I will do these other two product releases that we'll see later. So let's start with who am I? I'm Syrus Akbary. I'm currently CTO at try.com. But mainly, probably most of you know me because I'm the builder and main contributor of Graphene Python and the Graphene ecosystem. So let's start with Graphene Python. Let's do an overview. Graphene is about 2 years old now, actually exactly 2 years and 1 month old. It's the most started GraphQL framework with 2,500 stars and is used in more than 100 companies in production, including Yelp, Mozilla, Affirm, Dailymotion, and try.com. One thing that I want to go over is how the tremendous growth that Graphene has been having the last 10 months. And one surprising thing, but pleasant surprise, was discovering that Python 3 actually accomplished for more than 50% of all installs. Woo! Super good. Okay, so first major announcement. Today, I'm releasing Graphene Python 2.0, which have a better resolution API, a much simpler code base. That means that actually it's easier to contribute and takes full advantage of Python 3, which includes async iterators and class definitions. And last, I will do an overview about subscriptions and how we can use it in Python 3. So let's start with the better resolution API. Let's imagine we have this field in GraphQL, which is the hello field that takes a name as an argument and returns a string. In Graphene 1.x, this is how we will need to write the resolvers. So basically, this syntax or this API is super similar about how we will need to do it actually in GraphQL JavaScript. However, it was not as pleasant to use. And I've been thinking over how we can simplify and improve the way the API works. And with Graphene 2.x, actually the resolvers have been simplified a lot. The context is going again into the resolver info and name, and all the resolver arguments are actually keyboard arguments of that resolver. Cool. So let's go into subscriptions, which is one of the most challenging things that actually I did in Graphene. So if we want to start a subscription server, first, of course, we will need to plug a WebSocket server, WebSocket GraphQL server. We can see that only with 3 lines of code, we can have it running in Python, actually in Python 3.6. And then we'll need to create a subscription type. This subscription type is a normal object type, which is a little bit more special, that actually permits to subscribe to its fields. So in this case, taking advantage of Python 3.6 and its async iterators, we can see that, for example, if we had a field called count2 that let us count from 0 to whatever number we output, and it will yield these seconds, let's say from 0 to 10, and we'll wait 1 second between them. So if we want to do that, we only need to write 7 lines of code using Python 3.6 async iterators, and we are all done. I'm going to do a subscriptions demo, a real-time demo. Let's hope everything goes well. But actually, you can go into GitHub, GraphQL Python, GraphQL WebSockets, and try it by yourself if you have Python 3.6 installed. Yep. So now I'm going to set up everything. So first, I want to show you how the code looks. 1 second. So first, same code as I showed you before. Probably you can all see it, right? We have a query type, which is a type required when we create the schema, and then the subscription type. The subscription type have the count seconds that let us say up to what we want to wait. And then it will just yield these values and wait 1 second between them. So now let me just start the server and show it to you. OK, so if we go to localhost 8000 GraphQL. Perfect. Demo time. Oh, sorry. OK. So in this case, we want to like create a subscription and count out up to 10 seconds. If we execute that just like using the same syntax that you have seen, this is going to make it a little bit bigger. You will see that here it will count up to 10, like using WebSockets and this simpler API that you already seen. So that's a demo. That's a demo for subscriptions. I'm gonna go back to the presentation. Here we go. OK. So a part of Graphene 2.0 that I just released today, and I have like a new branding, a new website, a new logo that actually I'm like super excited about. Today I have another major product announcement. I'm presenting Graphene in JavaScript, which is the same framework, the same ideas, the same simple syntax and easy to use syntax that Graphene have, but in JavaScript. So what were the goals that I had when creating Graphene JavaScript? First, it should lead to very easy to read and easy to understand schemas. And then you should have like a way to integrate very easily with almost any data source, starting, for example, with the SQLized ORM. So for knowing or seeing like how Graphene JavaScript actually like how the schemas look like in Graphene JavaScript, it's essential to do a comparison between these two. So if we want to create a schema who have like a type query with a hello field on it, and this is how we will need to type in the schema in GraphQL JavaScript. And we can see how like exactly the same schema we can write it with just like half lines of code. So actually it makes the effort of creating a GraphQL schema much easier for the developer. But things get actually like much more funny when you go into types that inherit from interfaces. So let's say we have like an interface, we are a website that have two kinds of users. One is the anonymous user, another is the registered user, and both share the same fields. So actually both implement or extend the user-based interface, which have like an ID and a name on it. In GraphQL JavaScript, this will require us to write all this boilerplate code. And with Graphene JavaScript, actually, the code that is required to write is much less code. One of the cool things about Graphene JavaScript is actually implemented in TypeScript. So you will have auto-completion in your IDE. And also, you will have super easily integration with almost any data source. You can go into graphenejavascript.org to check like how you can use it. And right now, there are no documentations, but I will try to solve it by today. And you can actually start using, and I want to like basically like put it on the field and like start having people using it and see like how we can actually improve it. I also have another major project announcement, the third one. But for understanding this announcement, I think it's essential to tell a story about like how I came into it. So it's a story time. Okay, I want to start with templates. I've been loving templates and like how they work for a long time. I've been researching, like see like which ones go fast, which ones go slow. And actually, I launched my own template engine for Python, PyJade, 6 years ago. Which, if you don't know, like Jade was a template engine in JavaScript that was making much easier like write HTML code. Since then, I've been experimenting a lot between like in templates between JavaScript and Python, and I realized there are actually like two kinds of templates: the ones that are fast, and the ones that are not. So let's go very quickly into comparing two kind of template systems for Python, but this applies actually to almost any template engine, also in JavaScript or like in Ruby, in almost any language. So we can see that Django is about like 10 to 20 times slower than Jinja, which is another template engine. But why? For understanding this, it's essential to do an analysis on all the different, an analysis into like how the render function works in both template engines. So if we have this following template in Django, which is just checking if the user is authenticated, and in this case is returning the string, like hello. If we want to render this template with the following context, let's say the user is authenticated and its name is Peter, Django will actually render in runtime and returns hello Peter, but will run everything from the lexer to the parser to actually the execution engine in runtime. And that's super costly. And here we have Jinja 2 with exactly the same, or almost the same syntax. But what is the difference? Jinja 2 precompiles this code to actually pure native code, in this case, in Python. So it will create a Python function that takes a context variable, and it will return a string. So actually, once you generate this code, the only thing that you need to do is just run this function, which is pure Python. It runs in the Python engine, so actually it's as fast as it can be in Python. So both have exactly the same results, both Django and Jinja, but Jinja is 20 times faster. So I've been thinking lately, can we actually improve the speed that we query or GraphQL schemas? Can we improve the speed there? And the short answer is yes. So today, I'm presenting Quiver, which is the next generation GraphQL engine. And for that, I want to do another analysis into how these engines work and how it's different from the normal GraphQL engine. I guess you can already guess. So if we want to execute this following query, we want to query hello with the name that is provided from variables, and we want to execute this query. The GraphQL engine, either, and I'm talking almost in any engine, in GraphQL JavaScript, GraphQL Core, which is in the one in Python, GraphQL Ruby, both are executing these queries in runtime. And actually, the result is just like, hello, Peter, like what we expected. However, Quiver, when we have exactly the same query, what it's doing is precompiling this query into pure native code. That means that running a GraphQL query will be as fast as if you write the same query by hand, like exactly fetching the same information but doing it manually. That means that we will have actually zero overhead from the framework. But not just that. In the example of Python, we can even compile this to C and provide you with a library that you can just use it, and it will be executed in the speed of light. That's true. So here are some benchmarks. I'm comparing GraphQL Core, which is the main engine for using GraphQL in Python, with Quiver. In both like simple queries, highly nested queries, or very complex query with fragments, Quiver is from 5 to 10 times faster than GraphQL Core. So let me give you more stats. Actually, that means that we can actually do 300,000 resolutions per second in Python. And we all know Python is not a super performant language. And we can have up to 1 million resolutions per second using PyPy. But what are the cool things about here? These principles could be applied to almost any interpreted language. So this can be applied in JavaScript or anywhere that we want. And in general, we can see from 5 to 10 times performance in C, Python, and Ruby, and from 2 to 3 times performance in JIT-enabled and JIT-enabled backends. So PyPy, the V8 engine, SpiderMonkey, or even Hack. Quiver is going to be available in almost every major language, starting with Python, but it will be available also in JavaScript, in Ruby, and PHP. And if you're interested, you just have to go into graphqlquiver.com and contact the sales team, which in this case is me. I want to finish with this slide. Post data, your API is a user interface. This quote is from Kenneth Wraith, which is the creator of the request package in Python. And actually, it's one of the packages or libraries with the most beautiful API for like handling HTTP requests. I also want to finish giving thanks to almost everyone that like collaborated and like pushed Graphene forward to put it like where is it right now, from Patrick Armino adding Django REST framework into Graphene, Jacob Forster for being a very good contributor of Graphene Django. Basically, you can read, they did like some awesome work, and I would like to welcome more people into contributing to Graphene and into its side projects. Also, I know we are not doing questions right now, but if you have any questions, you can ping me personally. Also, you can check my Twitter at Syrus Akbary. And also, I welcome you to visit graphene.tools, where you can see like all the different tools from Graphene Python, Graphene JavaScript, and Quiver, and start investigating about them. Thank you.